To identify each tuple in a relation, the relation must have a primary key. The primary key is a unique value that identifies each row. This is the entity integrity constraint, generally the term's primary key constraint, and unique constraints are used. To implement these constraints, indices are used, which will be covered in detail in later presentations. Entity integrity constraint says that no attribute participating in the primary key of a relation is allowed to accept null values. For explanation purpose, I shall take the example of the relation author we have already seen in our previous presentation. As you know, author ID is the primary key for this relation author. Now, this key identifies each tuple in the relation. Suppose I say author ID A1. It points to the author Raul Chong from Toronto. It points to the author Raul Chong. What if I replace the value A1 with null? We can still identify the author Raul Chong. What if I replace A4 also with null? Now, which null would identify which row? Isn't that difficult? Hence, this constraint, integrity constraint, emphasizes on having no null values for the attributes playing the primary key role. Referential integrity constraint defines relationships between tables and ensures that these relationships remain valid. As mentioned in the very beginning of this presentation, for a book to exist, it has to be written by an author. Else, there is no meaning for just a book to exist all by itself. Triggers in relational database help implement this referential integrity constraint. Semantic integrity constraint. For this, let us see another example in the author relation. If the column city constraint some junk value like this instead of Toronto, does it give any meaning to the column name city? A semantic integrity constraint refers to the correctness of the meaning of the data. A domain constraint specifies the permissible values for a given attribute. As take the example of country attribute in our relation author, we know that this particular attribute must contain lettered country code such as CA for Canada, IN for India, etc. Supporting a value of 34 is entered. For the country, does it make any sense? No, right? Of course, unless there is another table which maps country codes in letters to that of numbers. But we do not want to induce redundancy, right? Null constraint specifies that attribute values cannot be null. Let us see what happens if in the author relation a null value for either last name or first name attributes is entered. It poses difficulty in identifying the right author just in case either the last name or first name is the same. This means an author must have a last name and a first name and not a null. Check constraints enforce domain integrity by limiting the values that are accepted by a column. Autorelation does not have a suitable attribute wherein the check constraints can be explained easily. So I will take the example of book relation. The year attribute is the year in which a particular book is published. Would it be meaningful to have a year greater than the current year 2010?